For this section of the training, we're going to discuss site drainage areas and contributing drainage areas. Now, these are two concepts that are important to understand for developing a stormwater management plan. The site drainage area is defined as all of the area that drains stormwater from the site to a single discharge point or sheet flows from a single area off the site, whereas the contributing drainage area, or the CDA, is defined as the area that contributes runoff to a best management practice, or a BMP. Let's look at this by using an example. So this building here in the example is going to undergo a major substantial improvement. The building is outlined here in red. The outline in green is all of the area that's going to undergo major land disturbing activity. So let's consider the site drainage areas for this site. So we can see there are two, defined by how the runoff leaves the site. You can see in this yellow area, all of the proposed grading and proposed stormwater piping is going to direct runoff generally up towards this top left and leave through this pipe that's connecting to the storm sewer in the street. It passes through a rain garden on its way, but what defines the site drainage area is how it ultimately crosses the lot line here and leaves the site. Similarly, the blue area here defines all of the area that is going to contribute runoff out through this exit point here, this pipe that's going to contribute runoff into this connection into the storm drain in the street. So again, this runoff passes through rain gardens and green roofs on its way, but what defines the site drainage area is how it ultimately all leaves the site through this exit point here. Let's look at the site drainage area number 1 in further depth. So we can look at it based on the cover types and the activities that are being proposed on this site drainage area, and we can calculate the swerve for just this site drainage area 1. So looking at the major land disturbing area, so this is the impervious cover outside of the building footprint, so the sidewalks and the other impervious areas that are proposed where the land disturbance is occurring, as well as the compacted cover, which is the grass and the landscaping that's proposed, and the BMP, which is the bioretention up there at the top left. So all of that area constitutes major land disturbing area, and we can see we've taken the land area for each cover type, multiplied it by the associated coefficient, and calculated the major land disturbing total swerve right here, 2,297. We can then look at the major substantial improvement component of this site drainage area and the impervious cover for the building footprint, that 9,125 square feet, so just this bit of the building here that's in site drainage area 1, that's going to be regulated at the major substantial improvement precipitation depth of 0.8 inches, so you calculate the major substantial improvement swerve of 578 cubic feet. So the total swerve for site drainage area 1 is the sum of the major substantial improvement and the major land disturbing swerve, which is a total of 2,875 cubic feet. We can then look at site drainage area 2, which is here in blue, and do the same. Look at the cover types for the major land disturbing activity and the cover type, which is the impervious cover only, for the major substantial improvement. So the part of the building here that is in site drainage area 2, and then all of this land disturbing area that's outside of it, including the BMPs. So there's a bioretention 1, 2, and then some green roofs that are proposed 1 and 2 there. So all of that area multiplied by the coefficient using the precipitation depth that corresponds to the activity, you can get again a swerve for this site drainage area 2. We can then look at the two site drainage areas together, and the total site swerve is the sum of the swerve for each of those site drainage areas. Now we want to look at the BMPs and look at the contributing drainage areas and understand that concept. So on this site, we've mentioned it, there are a number of bioretention BMPs proposed and 2 green roof BMPs proposed. So there's this bioretention up at the top, and then these 2 bioretentions here, and then 2 green roof areas. So you can see We've looked at the site drainage areas. So we had site drainage area 1, site drainage area 2. Now we can look at the contributing drainage areas where you have this bioretention A and the contributing drainage area A defined by this red line here. So all of the runoff that contributes flow to this bioretention is going to be the area of the CDA, the contributing drainage area to that bioretention. Similarly, for the other BMPs, we have the area here in blue that contributes runoff to this bioretention B, and the area in purple that contributes runoff to bioretention C, likewise for green roof D and green roof E. These are the contributing drainage areas, the areas that contribute runoff to a BMP. So let's look at the swerve, which is the retention required, in relation to the retention that's actually achieved based on where we're proposing these BMPs. So we calculated the swerve for site drainage area 1, which was 2,875 cubic feet. And now we want to look at the retention volume of the bioretention. And the retention volume of the bioretention is a function of two things. One, of how much runoff is contributed to the bioretention from the CDA, and how much runoff the bioretention can actually store, how much it can retain based on the sizing of that bioretention. So let's look first at how much runoff gets to the bioretention based on its CDA. So that's what we've done up here in this table. So you can see for each cover type within the CDA, we've listed the area. So the CDA constitutes this 56,122 square feet in 3 different categories. And the maximum retention volume, this is a concept that you need to understand for the contributing drainage area. The contributing drainage area is calculated up to the 1.7 inch precipitation depth. So essentially we're saying that these bioretention or any BMP can treat or manage the runoff from up to the 1.7 inch precipitation depth. Anything bigger than that we consider to be a larger storm that kind of it might bypass or isn't eligible for the treatment. So the 1.7 inch is the maximum retention. So for each of these land areas in the CDA to bioretention A, we can add up and find the 3,927 cubic feet that is possible. So this is the runoff that's reaching the bioretention, and that can be possibly retained depending on how we size the bioretention. But here we can see the retention volume of the bioretention. So this is based on the actual volume of the bioretention. It's a bit small for its CDA. So it's only retaining 2,576 because the bioretention is a little bit smaller compared to the volume of water that is flowing to it from the CDA. Now we can look at site drainage area 2 and the BMPs that are in this site drainage area. So we can see for each of these 4 BMPs, there is a maximum retention volume associated with the contributing drainage area that contributes runoff to the BMP. And then there is a BMP retention volume, which is based on the sizing of the BMP. So for each of these, we'll take the lower of these 2 numbers. So for bioretention B, for example, it can retain up to 997 cubic feet of flow or volume because the contributing drainage area only contributes that much up in for the 1.7 inch storm. The bioretention has additional capacity, but a smaller volume is reaching it, so we take the lower of the 2 numbers. Same thing for bioretention C, green roof D, and green roof E. So you can see in these cases, the bioretentions are both oversized, right? They have additional capacity that is not being utilized based on the contributing drainage area. Whereas the green roofs are undersized, so the size of these green roofs is smaller. They have less capacity than the volume that is being received from their contributing drainage area. To find the total retention that's achieved by these 4 BMPs for this site drainage area 2, we look at the sum of everything in these red ovals here. So adding up these four numbers in the red ovals, we get a retention value of 4,327 cubic feet. So that is the retention achieved in this site drainage area 2, which is greater than the swerve that we were trying to achieve. Looking at both site drainage areas together, this overall site, we can see that for site drainage area 1 and site drainage area 2 together, we needed a 6,753 cubic feet. That was the swerve for the site overall. And we achieved a retention of 6,903. So the stormwater obligation is met for this site. And it was done by using what's called over control, where the actual retention in site drainage area 2 was higher than the swerve. So those 4 BMPs achieved more retention to compensate for the fact that BMP A in site drainage area 1 had less retention than was needed for that site drainage.